In episode 46 of the CySec101 training series, we're going to go through the fundamentals of IDS systems, and these are intrusion detection systems. Very, very important software, very important tool in our toolkit when it comes down to security analysts and security engineers. And this is a part of the security solutions module that is a part of the cybersecurity 101 pathway of TryHackMe. And as a part of this video, we're going to go through what an IDS actually is. We're going to go through the various types of IDS systems, or IDSs. I guess technically IDS stands for intrusion detection system. And then we have the IDS example, which is Snort, a command line based intrusion detection system. And then we have the Snort Usage portion, where we actually will end up using Snort. And of course, we have a practical lab that will issue us some challenges, and we're designed, or we are meant to go ahead and accomplish those challenges and solve those challenges so that we can complete this room. So I'm very excited about this one. I want to share this with you. Snort is a very powerful tool. It is open source and it can do a lot of amazing things if you know how to use it. And there's several other videos on Snort that are already on this channel, but we are approaching this from the perspective of Cybersecurity 101, CySec 101. So if you've never used an IDS before, or if you've never used Snort before, then you're in for a treat, and this is going to be a great video. So I'm excited to share it with you. If you'd like to support this channel and get access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the supporter, agent, guardian, and master. Each tier gets their own Discord server and early access to content. The agent, guardian, and master levels get exclusive content, bug bounties, exclusive downloads, monthly Python automations, live streams with me, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. Now, without further ado, let us jump into the IDS fundamentals room. In the last video that we did on the CySec 101 series, we talked about firewalls, and firewalls act as the first line of defense when there is traffic coming into your network or connecting to your specific device. But what happens after certain packets or certain connections have passed the firewall, but they are still considered to be malicious, right? So there should be some kind of security to detect the activities of the connection that passed through the firewall and have already taken place. So if an attacker successfully bypasses your firewall via a legitimate looking connection and then performs some kind of malicious activity inside your network, there should be something to detect it timely, meaning quickly, as fast as humanly possible. So for this purpose, we have security solutions inside of the network, and that is known as the intrusion detection system. So think of it as an example of a building's security. And so the firewall acts as the gatekeeper, meaning the security guard that checks the people coming in and going out. And there's always a chance that some bad actor will successfully sneak inside and start performing malicious activities. And he was missed at the gate, right? The security team didn't know him or didn't notice him, or maybe they just thought that he was like a legitimate person. But what if we catch him even after he gets in? This can be done by surveillance cameras present throughout the building, and the IDS plays the role of the surveillance camera in this instance. So it sits in a corner, monitors the network traffic based on the signature and anomaly-based detections, and detects any abnormal traffic going out or in the network. Upon every detection, an alert is generated for the security admins, which will be you or me, and the IDS does not act on those detections. It simply notifies you. So there's something called an IPS, which is an intrusion prevention system, and that actually acts on whatever the detection is that it does detect. IDS does not act on anything. It simply just notifies us about what's going on, and then it's our job to respond to it in a timely fashion. So this is our little animation, and the packets are going in and out from the network. So this is technically coming from outside of the network, assuming that it's going through the firewall first, and then the firewall stops the malicious packets from going through, and then something does end up going through and it ends up at the computer. So technically this is just a firewall doing what it's supposed to do, but whenever it lands at the computer, it's supposed to detect any other malicious activity through the IDS. So this is what we're going to be talking about in this video, which is the types of IDS and their detection capabilities, working of Snort IDS, and then the default and custom rules in Snort, and then making our own custom rule in Snort. So this is a really good one. I'm excited about this one, and I think you're going to get a lot of value out of it. The first question is, can an intrusion detection system prevent the threat after it detects it? And the answer to that would be nay, because it only detects it. So let's talk about the types of IDS. Intrusion detection systems can be categorized differently depending on a few factors, and the main categorization depends on the deployment and detection modes of the IDS. So the deployment mode can be either the host-based or an host intrusion detection system, or it could be a network intrusion detection system. And so, as the name implies, the host intrusion detection system is installed individually on the host. So that could be the web server, it could be somebody's computer, anything like that. So it's the individual host itself. A host is basically another term for a computer, essentially. So that provides detailed visibility of the host activities, and the host intrusion detection system can be challenging to manage in large networks because they are resource intensive and require management on each host. So this would be ideal for smaller networks, we would say. Network intrusion detection systems, or NIDS. I guess HIDS and NIDS. I don't know if that's the thing, but in this case, we have the NIDS. So they act based on the activities of the network, right? So they detect potentially malicious activities within the entire network, regardless of any specific host, and they monitor the network traffic of all of the hosts involved to detect suspicious activities, and it has a centralized view of everything that it detects inside of the network. So the HIDS, the host-based intrusion detection system, you have the traffic that goes through the firewall, and then it hits the host intrusion detection system. And then we have the traffic that goes through the internet, it gets through the firewall, it goes through the network intrusion detection system, and then from there it actually gets passed on to the individual machines. Then we have the detection modes. So signature-based IDS is another term for heuristic. So we talked about heuristic firewalls in the last video, and heuristic and signature-based essentially act as in the same way. So the attacks that occur daily, or the attacks that have been documented, right? They have some kind of a unique pattern, or at the very least, we can call it a signature. It could be in the form of its actual source code. It could be in the form of its hash value, its checksum value. And these signatures are preserved by the IDS in their databases, so that if the same attack happens in the future, it gets detected by the signature and reported immediately to the admin. The stronger the signature database of the IDS, the more efficiently it would detect known threats. However, the signature-based IDS is unable to detect zero-day attacks, because zero-day attacks imply that they have never happened before. This is the first time that it's being detected. Therefore, there is no signature. There is no known signature that exists in the IDS database or any other type of database. So the signature-based IDS can only detect attacks that actually happened before, right? There's some kind of a signature or a pattern that exists inside of a database. That's how it can detect it. Apart from that, it can't do anything as far as anomaly detection is concerned. And the IDS that we're going to be dealing with that is signature-based is going to be the Snort IDS. Now, an anomaly-based IDS is the type of IDS that learns the behavior of your network. This is known as your baseline, right? So this is what normal behavior is supposed to look like. So that takes some tweaking and some fine-tuning in order for the IDS to really know what your normal baseline is supposed to look like. And then from there, it'll essentially detect anything that deviates from that normal behavior. So anything that is outside of the norm is what the anomaly is going to be. So anomaly-based IDS can also detect zero-day attacks because they don't rely on the available signatures. They detect anomalies inside the network or system by comparing current state with the normal behavior, which would be the baseline. This can generate a lot of false positives, and it requires a lot of fine-tuning, which is why I mentioned it at the very beginning, because it could detect anything that may seem out of the ordinary and be like, yeah, there's a problem here, and then you have to say, no, this was fine, this was, for whatever the adjustment is that you have to make, so that you constantly are training the IDS so that it knows what the legitimate baseline actually looks like, and it doesn't generate too many false positives. It's also known as being noisy, right? So if it's too noisy, then the actual attacks, the actual threats are going to get past you because you have too many things, too many alerts to deal with. So this is one of the big kind of drawbacks of having an anomaly-based IDS. But once it's been trained and it's been tweaked and fine-tuned and optimized, at that point, it'll be really, really successful. So we can reduce the false positive generation by fine-tuning it, manually defining normal behavior. And then we have the hybrid. The hybrid IDS combines the detection methods of the signature IDS, the signature-based and anomaly-based, to leverage the strength of each approach, and some known threats may already have some signatures in the IDS database. In this case, the hybrid IDS would use the detection technique of the signature-based IDS. If it encounters a new threat, it can leverage the detection method of anomaly-based IDS. So this is probably the best thing if you can afford to get one, because I can't imagine that they would be cheap. So that would be the best one, and I think it would also be the most resource intensive. So it would be the most expensive to purchase, and it would be the most expensive to maintain because it requires a lot of bandwidth, a lot of power for it to process. So signature-based IDS can detect threats quickly, while the other IDSs have a high processing overhead. However, it's also essential to consider the IDS based on several different factors. Signature-based can be a good option for covering a small threat surface. Anomaly-based and hybrid can detect modern zero-day attacks, which are increasing daily and can cause massive damage to the organization. So which type of IDS is deployed to detect threats through the network? And this would be our network intrusion detection system. Here we go. Cool. And then the next question is, which IDS leverages both signature-based and anomaly-based? And that would be the hybrid IDS. And that's it. All right, cool. Let's talk about Snort. Snort is a very popular IDS. It was developed in 1998. It actually has signature-based and anomaly-based detection, and these are done in the rule files that come with Snort. When you install it, there are several rule files that come pre-installed in the package, and these files contain a variety of known attack patterns, also known as signatures, right? So Snort's built-in rules can detect a lot of malicious traffic for you. However, you can configure it to detect types of traffic of network that are not covered by the default rules, and you can create custom rules based on your requirements to detect specific traffic. You can also disable any built-in detection rules if you don't, or if they don't point to harmful traffic for your system or your network, because they would actually cause noise, right? There would be false positives, or they just are irrelevant, so they're taking up processing power. And then you create custom rules instead. So what we're going to be talking about is how to actually explore those built-in rules and how to make our own custom rules. So we have the packet sniffer mode inside of Snort. We have the packet logging mode, and then we have NIDS mode. And of course, as the name implies, snort is something, that pigs do. That I can't. There you go. That's a pretty good snort noise. And yeah, so we have the piggy that is doing all of the sniffing for us. So these are the various modes that we have. Packet sniffer reads and displays network packets without performing any analysis. It just sniffs, and it does not directly relate to the IDS capabilities, but it can be helpful in network monitoring and troubleshooting. In some cases, system admins might need to read the traffic flow without performing any detection to diagnose specific issues. In this case, they can utilize the packet sniff mode. This allows to display the network traffic on the console or even put it into a file. So an example would be, or a use case would be, the network team observes some network performance issues. To diagnose the issue, they need detailed insights to the network traffic. For this purpose, they use the packet sniffer. Packet logging is the detection of the network traffic in real time and displays the detections as alerts on the console for the security admin to take action. However, in some cases, the network traffic needs to be logged for later analysis. The packet logging mode of Snort allows you to log the network traffic as a PCAP file. And this is what we used or what we were analyzing when we were doing the Wireshark room. So a packet capture file is .pcap. That's the extension for those files. And this includes all the network traffic and any detections from it. Forensic investigators use these log files to perform the root cause analysis. So the security team needs to initiate a forensic investigation of a network attack. They would need the traffic logs to perform the root cause analysis, and the network traffic logged through Snort packet logging can help. And then we have the NIDS mode. So this is the primary mode that monitors network traffic in real time and applies its rule files to identify any match to the known attack patterns stored as signatures. If there's a match, it generates an alert, and this is the main functionality of an IDS solution. So the security team must proactively monitor their network or system to detect potential threats. They can leverage the NIDS mode to achieve this. So the most relevant use of Snort as an IDS comes from the NIDS. However, Snort can be used in any of the above modes. Which mode of Snort helps us to log the network traffic in a PCAP file? And this is the packet capture, right? Or packet logging, excuse me. So packet logging mode. And what is the primary mode of Snort called? And this is the, what is it? It's like network intrusion detection system mode. Oof. Network intrusion detection system mode. Boom. Nice. All right. Now we're going to get to use it. Nice. So you can either run Snort normally, where it only captures the traffic intended for the host, or you can use it to capture and detect intrusions. And to do that, you have to turn on the promiscuous mode of the network interface on our host. So we have a virtual machine that I've already started, and it's running. The built-in configuration files or the built-in rule files are going to be inside of the configuration directory or the configuration partition. I don't think it's a partition. It's actually one of the main directories that just holds all of the configuration files, excuse me, inside of Linux. So in this instance, we are going to have another directory called Snort inside of the etc directory that holds all the configurations. And inside of the Snort directory, we have all of these various files that come pre-installed, and they are configuration files, right? So we have rules in here as well, and the Snort configuration file is the key file where you can specify which rule files to enable and which network range to monitor and enable other settings. And the rule files are stored in the rules folder that we can see over here, and we can create or modify them. So this is the rule format. Let me see if I can get you any kind of a good view here. Let's see. There you go. That's pretty good. So this is the average rule. This is what a rule looks like. So the first thing is the action that you want it to take, which is going to be an alert in this case. The very next one is the protocol that we are monitoring. So in this case, it is a ping ICMP, right? ICMP ping. The source IP and the source port. And then this is the direction. So this piece right here, that is the dash forward or the dash greater than symbol or whatever. So that is the direction of where it's going. So we're saying from any source port and any source IP to this destination IP, which is our home network, on any destination port, I want you to do this. And so essentially, this is all of the attributes of the alert that are going to be generated. There is going to be a message attached to it, which is ping detected. There is the SID, which is the signature ID for this, and it needs to be unique for every single rule. So you have to have a unique SID for every single rule. This part's very important to understand. And then the rule revision is, in this particular case, the very first revision. So this is also just for your own tracking for all of the rules that you're creating. But for the most part, this is the most important. If you have multiple rules, the SID needs to be unique for every single rule. And if you recreate this specific rule multiple times, you could have a revision of 1, 2, 3, however, right? So this is the action. This is the protocol, the source and destination port, the direction, that it would go, and it could be in both directions, right? It could be a less than and a greater than symbol, and that would imply that in either direction. And then in this particular case, we're saying that it's going from any source port or source IP address to our home network or home net device right here. And then from here, we're going to have any port on our home network. And that's what we want. So in this particular case, there's a ping that's been detected that's going from these places to our home network, right? So that is pretty much what I explained. So I'm very, very happy about that. And now we can go into the rule creation. So we're going to paste the sample rule explained above into the custom local rules file in the Snort directory. So we're going to open it, and then we're going to paste it, and then we're going to test it by using the snort command. So when we start the snort tool to detect any intrusions defined in the rule, for this we have to execute it with sudo privileges. So you would do sudo snort, and let me see if I can zoom in on this a little bit for you. Let's see how this works. Boom. Okay, that's better. So we could do sudo snort, and then quiet mode, meaning we just don't want it to display everything onto the screen. We are going to be listening, or excuse me, logging this specific file. We're using this specific snort location, or excuse me, what am I saying? We're putting it, I believe, from this specific file. I should probably read all of those to see what the options are, but for the most part, I believe what we're doing is that we are using this specific log location is where we're going to create the log, and then the interface is going to be our local interface. And then we are going to alert on the console, and then the configuration file that we want to use for this is the snort configuration file. So I apologize for being a little bit unsure about this, but it's been a while since I've used snort, so I just had to remind myself of all of these things. So in our case, the loopback interface is not called LO, so replace it with the correct interface name, and then we're going to ping the IP address, which is going to be our loopback IP address, which is this. This is the IP address for every loopback for every single machine. And then the screenshot below shows the snort generated loopback ping detected, which is going to happen as we run it. So essentially, we're going to be doing this in a different terminal. And that's pretty much it. And then running it on PCAP files is another version right here. So we saw that you can use it in a PCAP file to detect it. And you have to perform a forensic investigation in that case, for example. And this is usually logged in that PCAP. And so it's equipped to perform detections, and we can just run it as such. So again, same thing, sudo snort, quiet mode, and we're going to use, throw our logs in here. And then the read of the PCAP, right? So in this particular case, it was saying the interface that it wants to interact with is the local or the loopback interface. In this case, it's reading the PCAP file. And then again, the alerts are going to come into the console. And then we are using this configuration file to go through it. So replace the task PCAP with the path to your PCAP file for analysis. And that's it. So first, we're going to answer as many questions as we can, and then we're going to go and run that example that we had. So where's the main directory of Snort that stores its files? And that will be etc snort. And then, excuse me, which field in the snort rule indicates the revision number of the rule? And that would be rev. Which protocol is defined in the sample rule created in the task? And that would be ICMP. And what is the file name that contains custom rules for snort? And that would be the snort.configuration. Oh, is it not configuration? Snort dot, I thought it was configuration. Is that it? No. Let's see. Excuse me. So it is actually the local dot rules, I believe. That would be the answer. So let's try that one. I think that's the answer, actually. Local dot rules. That is indeed the answer. Okay, so before moving on to the practical lab, I do want to just kind of try this out that we did over here. So we are going to first and foremost and we're going to go open up this specific local.rules, and we're going to add this rule that we have over here to it. So I'm just going to copy this to make it a little bit quicker. So we are going to do sudo nano, and we're going to open up etc snort rules and then local.rules. And these are our local rules that we're going to use. And then at the bottom, oh, this is already added. That's so insane. This is already inside of our thing. So from ICMP any 127001, do I have it? ICMP any, oh no, that's it. That's for the home. Okay, so boom, we're just gonna add this right here. I'm just gonna paste it at the bottom right there. Boom, there we go. And then, what did I just do? Okay, no, that's great. When I backspaced, it took me to the end of that, and it looked like it deleted it, but we are all good. Okay, so cool. So we're going to do Control O to write it, and we're going to press enter, and then Control X, and we're going to get out of that. And so now we get to run snort, and we need to run it using this specific file that we created, right? So the snort configuration file is going to use these rules that are inside of our local rules location. So the command itself that we're going to run is this piece right here, where we actually run it to detect it, and we're going to do it against our local or loopback interface. So we need to find out what that is. So I'm going to do ifconfig. So I mean, I know for a fact that it's not ipconfig because we're in a Linux machine. So ifconfig is not in my path. That's so interesting. So it's available in the following places. So I guess I would technically need to do sbin ifconfig. There we go. That's so weird that it's not in my path variable. That's so nuts. Okay, I mean, my loopback is literally LO. So I don't know why they're saying that it's not in my loopback, or it's not called. In case your loopback is not LO, replace it with the, oh, I see. It says in case it's not LO. I see. That's so fucking, okay. All right. Excuse my French. My bad. Okay, cool. So, it is technically called LO, which is fine. So now I'm going to write this is exactly what I'm going to write letter by letter. This is the command that I'm going to run right here. So we'll do sudo snort. Boom. It is now going to run, or I believe it is currently running. So I'm going to open up another terminal, and I'm going to do ping 127001. And then we're going to run it, and boom, in the background, we notice that we are getting all of these loopback pings detected, which means it's actually working. So I'm just going to stop that from running so it doesn't keep creating these. But look, it worked exactly as we thought it would. So it's actually working, which is excellent. And we have successfully tested our snort rule. So very, very exciting stuff here. Then we're also going to stop snort from running in this window. So now snort is not running anymore, and that was the command. Very literally the same exact command that we had before, or we had in the instruction sudo snort in quiet mode, and then we're going to do L verilog . In quiet mode means that all of the stuff that is going to normally print, we're not talking about the alerts, right? Because the alerts in this specific case are actually supposed to come onto the console. We're not talking about alerts. We're talking about each individual action that snort is going to take as it's running everything. That's what we're going to run in quiet mode. And typically that's kind of like the default instruction that we're going to get throughout all of these rooms. And it makes it a little bit easier, especially if you're trying to generate the alerts onto your console. It makes it less noisy. It creates less output that's going to come onto the screen, which makes it a little bit easier to handle. So then we can use the pcap file. So let's see where our pcap file is, and I'm going to use it in this window. So I will run the ls command, and I mean, it could be anywhere really. So let's go to the desktop just in case. We have mate terminal.desktop. I don't think that's it. So let's do, I could always search for it too. There's nothing in there. So why don't we do this? We're just going to do cd back, and then we'll do find inside of our root a file, or I think it's file like that. And then we'll do by the name, and then we'll give it an asterisk, and or let's do it in the quotes asterisk pcap like that. And now we'll do to dev null. Let's see if that works. Nothing showed up here. So let me change from file. We're just going to say find me anything that ends with a pcap. Let's see what it finds. All right, cool. So there is, all the stuff in our trash files. And then we have the intro to IDS pcap, which is inside of the Snort directory. And did they say that it was over there? I wonder if they actually showed it at the very top. It does not show it over here. Okay, so I did not miss it. I thought that maybe I missed it. But it is inside of the Etsy Snort location. So we got that going. And so now we can just run it on the pcap file. And what are we going to analyze it for? I'm not really sure what we're going to analyze it for, but we're analyzing the pcap file. So let's do it. Let's see if we have any specific questions. Sudo snort. And so what does it say? It's getting a stat on the pcap file. Oh, I see. My God, I forgot to change it to the location of my pcap. So it's not task pcap. It is technically the Etsy Snort intro to IDS .pcap. That's what it is. Okay, there we go. There we go. Now we got it. So this is the data, and so there's SSH connection detected. These are all of the alerts that were previously generated. And on 7/18, the last one was generated. And then today, there should have been one. No, these were also on 7/18. So ping detected, priority, So this is the last pcap. This is not an update on any of our activities. This is just old stuff from July 18th of whatever year. I'm not exactly sure what year this would be. It just says July 18th. So anyways, this is how you read a pcap file using Snort, and then you would need to extract your data accordingly depending on whatever you're looking for. So that's it. So we ran Snort in the alert mode. We pinged ourselves, and we saw those alerts actually show up. And then we also read a pcap file using Snort. So based on this information, we are now going to actually run this practical exercise. So let's see what the scenario is. Okay, so we're literally supposed to run it on the intro to IDS pcap, which I already did, so I don't even need to worry about that. They're telling us to change our directory to Etsy Snort, but you can also use just the path to it. So you could do /Etsy/snort and then do intro to IDS at the end of that, which is exactly what I did right here. So just to kind of give you the sample command that I used. So let me zoom in here. This is the command that I actually used over here. And instead of switching my directory to the Etsy Snort and then running it on this file, I just basically said read that file, and I gave it the full path to the file, which is what you see over here. And then we had all of this output that you also see on the screen. So now, what is our investigation? It says, what's the IP address of the machine that tried to connect to the subject machine using SSH? So if we go over here, these are all of the SSH connections, right? So it says SSH connection detected, priority, TCP 10.11.90.211 to 10.10.161.151 on port 22. So this is the one that actually tried to connect, right? So this is the one that was actually sending that SSH request to our port 22, right? Because if this is what's being connected to and it's on port 22, that means that's the target. And then this guy on port 54,334 was the one that was trying to connect. So that's that. What other rule message besides the SSH message, SSH message is detected in the PCAP file. And this is the ping detected that we see right here. That's the other message that we got. So let's just type that. And then what is the SID of the rule that detects the SSH? And we have this over here as well. The SID is 1 or 100,000. Is that 100,000? No, it's 1 million. 1,000,002. That's the SID. So we're going to copy that. Go over here. Paste that. And we're officially done with the... There we go. We're done. Congratulations on completing the IDS fundamentals. So, I mean, you saw that that was not difficult to do. You saw how simple it is to actually add a new rule to the configuration file that we had, or the rules.local file technically. And then from there, we were able to run it using the configuration file. And then we ran it in a live capture environment. And we also ran it against a PCAP file. And then we did our investigation on it. This is extremely beginner stuff. If you're interested in looking at Snort in the variety of other options that we have, and then doing like a really deep dive into the rule creation, I would highly recommend you actually check out the Snort videos. There are multiple Snort videos on this channel, and you are more than welcome to go check them out if you want to do some independent study and learn a little bit more about Snort and how to use it as a network intrusion detection system, and how to read PCAP files and how to create rules. So I think it's a very powerful tool. I think it's very useful. It's free to download in case you want to do it for your own computer and you want to kind of set it up as a network intrusion detection system for yourself. If you really want to do that, I would recommend going and watching the rest of those videos. But that was pretty much it for the Snort IDS fundamentals video. If you got any value from this video, and if you would like to get more videos like this one from the CySec101 training series or anything else that's on our channel, I encourage you to like, subscribe, and turn on that notification bell so that you get notified the next time that a video comes out, especially on these playlists and everything else that we're going to be talking about. So if you have any comments, drop it in the comment section. If you have any questions, drop it in the comment section. I will respond to them as soon as I see them. I'm pretty good with responding to the comments quickly. And that's pretty much it. I hope you got value from this. I hope you actually are going to use Snort and you're going to go through these exercises, because it's a very, very useful tool and a very useful skill set to have. So again, make sure that you like, subscribe, and turn on the notification bell so that you get notified the next time that a video comes out on this channel. If you'd like to support this channel and get access to me on Discord, consider joining Hackaholics Anonymous. We have 4 tiers: the Supporter, Agent, Guardian, and Master. Each tier gets their own Discord server and early access to content. The Agent, Guardian, and Master levels get exclusive content, bug bounties, exclusive downloads, monthly Python automations, live streams with me every single month, plus so much more. And to join, you can simply click the link in the description below, or you can go to our homepage and click the join button there, or you can go to youtube.com/@HankHacksHackers/join, and you will be able to join Hackaholics Anonymous. I hope I see you in the Discord chats. If not, I hope I see you in the comment section, and that's it. This is your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker/protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease, and I'll see you in the next video. Later.